how are you all? I hope you all are fine. Let us start our today's session. In today's session, we are going to learn a new chapter of mathematics, that is chapter number 3, Understanding Quadrilaterals. The name of our new chapter is Understanding Quadrilaterals. So my dear students, all of you know about quadrilaterals. Quadrilateral has 4 vertices and 4 sides. So in this chapter, we are going to learn some basic concept about quadrilaterals, also some basic concept about polygons. So be ready my students for new concept. So let us start our today's session. Now look at the board. Here the first column contains some figures and the second column contains types of figures. Okay, the first column contains figures and the second column contains types of figure. So read this figure and type carefully and tell me the patches of the figure. Okay, so look at the first figure. So can you tell me this figure is matched with any of the type of second column? Yes. The columns are simple, closed, curve. A closed curve that is not simple. Simple curve that is not closed. Not a simple curve. So now tell me, this figure is matches with? Yes, it is a curve. But this curve is not closed curve. This curve is open curve. So this figure is matches with? It is a simple curve that is not closed. Simple curve that is not closed. So figure 1 matches with C. Now look at the third figure. Third, it is a circle and circle is a closed figure and also it is a circle. So circle 3 matches with A. Simple closed curve. Look at the fourth figure here. Fourth figure, this is a closed curve, but it is simple? No. So, not a simple curve or a closed curve that is not simple. That means 4 matches with B. The closed curve that is not simple. And the last one, it is not a simple curve. It is not simple curve. It is not closed or it is not open. Look at here. This figure is not closed or also not open. So, it is not a simple curve. That means figure 2 matches with the type not a simple curve. Okay students, we have already studied the simple curve or the closed curve and open curve in your earlier classes. Okay, we just recall this. So discuss this with your friends. Okay, figure and type of the figure. Now next point is polygons. Now what is polygons? Look at the figures here. Okay, first one is what? Curves that are polygons. Okay, so this shows that the above curves are polygons. Next one, curves that are not polygons. That means the above figures which are not polygons. Now observe these two figures. Observe this figure number 1 and figure number 2. And tell me, what is the basic difference between these? How can we define polygon? Yes, look at carefully. These are some figures of polygons and these are figures of non-polygons. So what is the basic difference between these two polygons? Look at here. These 3 figures. These figures are simple closed curve, right? All these figures are closed curve. And look at here. This curve is closed? No. It is not closed. This curve is closed? No. It is also not closed. It is a closed curve, but it is simple? No. It is complex curve. It is not a simple curve. So all these 3 figures are not closed curve and they are not simple. But look at these 3 figures. These are simple closed curve. So how can we define polygon? A simple closed curve made up of only line segment is called as polygon. A simple closed made up of only line segment is called polygon. All of you understood? Okay. Now, look at these two figures, interior and exterior. Okay, so my dear students, you already know what do we mean interior and exterior of the closed figure? Yes. Now, this figure shows interior part of the closed curve and this figure shows exterior part of the closed curve. Now, tell me what is the basic difference between interior part and exterior part? Yes, correct. Interior part has a boundary. Interior part has a boundary. Okay, this boundary, right? The boundary of the closed curve. So interior part has a boundary. So does exterior part have a boundary? Yes? No. Exterior part have no boundary. Okay. So interior and exterior. Okay, what is the basic difference between interior and exterior? Interior part has boundary and exterior part does not have any boundary. Okay, so up to this we have learned simple closed curve, also polygons. Polygons means what? A closed figure or a simple closed curve made up of only line segment is called as polygon. Okay, now depending on number of sides and vertices, depending on number of sides and vertices of polygon, polygons are classified into different categories. Okay, according to number of vertices or number of sides of that polygon, polygons are classified into different categories. Now look at this chart. This chart have three columns here. First one is number of sides and vertices. Second one is classification, and third one is sample figure. Now first look at the column sample figure. Look at this figure. This is all these figures. These all figures are closed curve and they are all simple closed curve. Look at this figure. These all figures are closed curve and they are simple closed curve. They are only made up of line segment. Look at the figure. They are only made up of line segment. So all these figures are polygons. All these figures are polygons. And depending on the number of vertices or number of sides, we can name this figure as some type of polygon. Okay, so look at the first figure. All of you know that this one is triangle, right? And triangle has three sides and three corners, right? Triangles have three sides and three corners. So, and triangle is a polygon. Why it is polygon? Since it is a simple closed curve made up of line segment. So, this type of polygon is called as triangle. So, that means the polygon having three sides is called as triangle. Triangle is a basic name of triangle is polygon, but polygon having three sides is called as triangle. So we call this polygon as triangle. Now look at here 1, 2, 3, 4. 4 vertices and 4 sides. So 4 sides polygon is called as quadrilateral. Right? 4 sides of polygon is called as quadrilateral. Now next one is, look at here 1, 2, 3, 4 and 5. So this polygon contains 5 sides and 5 sides polygon is called as pentagon. Also 5 vertices 1, 2, 3, 4 and 5. 5 sides or 5 vertices. So 5, the polygon having 5 sides is called as pentagon. Polygon having 5 sides is called as pentagon. Now polygon having 6 sides 1, 2, 3, 4, 5 and 6. Polygon having 6 sides is called as hexagon. So hexagon is nothing but a polygon, but it having 6 sides. So it is called as hexagon. A polygon having 7 sides 1, 2, 3, 4, 5, 6, is called as octagon. Octagon. Polygon having 9 sides. 9 sides or 9 vertices are called as nonagon. And polygon having 10 sides or 10 vertices are called as decagon. Okay? So remember these words. Classification of polygons. Polygons having 3 sides is called as triangle. 4 sides is called as quadrilateral. 5 sides pentagon. 6 sides hexagon. 7 sides heptagon. 8 sides octagon. 9 sides nonagon. 10 sides decagon. Okay? So depending on number of types, number of sides, we name the polygon is one of the type. We name that polygon as some triangle, quadrilateral, pentagon, hexagon, and so on. So this is all about classification of polygons. Okay. Now in this lecture we are going to learn one new concept, which is diagonals of polygon. Now what is diagonals of polygon? Look at it. It's a very simple concept. A diagonal is a line segment connecting to non-consecutive vertices of a polygon. So it is very important word. A diagonal is a line segment. Diagonal is nothing but a line segment connecting to non-consecutive vertices. Now what is meant by non-consecutive vertices? All of you know that the consecutive numbers, right, 1, 2, 3, 4, 5 and so on are called as consecutive numbers. Now look at here, which vertices are called as consecutive vertices? Look at the figure. The first figure, this is a rectangle. Why it is rectangle? Since it has 4 sides and 4 vertices. So this is a polygon. Since it is a simple closed curve made up of 9 segments, so it is a polygon. Now we have to find diagonal of this polygon. For this, first look at here, consecutive vertices. Here A is the vertex. Okay, the vertex A is connected with vertex B and the vertex B. Right? Vertex A is connected with the line segment vertex B and the vertex B. So therefore B and B are called as consecutive vertices of A. Okay? The vertex A is connected with B and B. Okay, so there is line segment between AD and AB. So B and B are called as consecutive vertices of A. Okay, now tell me, what are the consecutive vertices of C? So look at the vertex C. Now C is connected with what? B and P. C is connected with B and P. So B and D are called as consecutive vertices of that vertex C. So now look at here. A is connected with B and B. So B and D are consecutive vertices. But A and C is not consecutive vertices since there is no line segment between A and C. First of all, I will draw this. Okay. Now look at the figure here. A is connected with B and B, but A is not connected with C. So A and C are called as non-consecutive vertices. Okay. Between A and C, there is no line segment. So A and C is called as non-consecutive vertices. And a diagonal is a line segment connecting to two non-diagonal, non-consecutive vertices is called as diagonal. So if we connect A with C, A and C, then AC is the diagonal of this figure. AC is the diagonal. Since A and C are non-consecutive vertices, and if we connect A and C, then that AC is called as diagonal of the polygon. Okay, now tell me another pair of vertices which is non-consecutive. Right, look at here. B and D. There is no line segment between B and D. Okay, there is no line segment between B and D. So B B are called as non-consecutive vertices. And the line segment connecting to B and D, the line segment connecting to B and D is called as diagonal of that polygon. So here what are the diagonals of this figure? What are the diagonals? AC and BD. So here AC and BD are diagonals of this figure. Okay, so you understood how to calculate or how to draw diagonals of a figure? Yes. Now look at the next figure here. Here the line by the color blue color. Okay, this is a figure. That means figure. Okay, I will draw this. You will get a better idea. Look at it. Now P Q R S. It is a closed figure. So it is a polygon. Why it is polygon? Since it is a closed figure. Okay, it is a simple closed curve made up of line segment. So this is our polygon. Now we have to find diagonals of that figure. So now what is diagonal? Diagonal is the line segment connecting to non-consecutive vertices. Connecting to non-consecutive vertices of the polygon. So look at here. P is connected with Q and R, but there is no connection between P and S. That means P and S are non-consecutive vertices. So we join P and S by the line segment. So we get here PS is diagonal since P and S are non-consecutive. Also, next one is what? Next step is, look at here. Q is connected with PS, but Q is not connected with R. Okay, there is no line segment between Q and R. So Q and R are non-consecutive vertices. So if I join Q with R, we get the second diagonal of this figure, which is QR. So PS and QR are diagonals of this figure. Now get this? Okay. Now look at the third figure and tell me what are the diagonals of this figure? Now this figure is 1, 2, 3, 4 and 5. 5 sides. So this polygon is named as pentagon. Right? 5 sides. 5 sides polygon is called as pentagon. So here is the pentagon. Okay. So the dotted lines. Here the dotted lines are the diagonal of this figure. Now tell me what are the diagonals? Here. Look at here. R. The vertex R is connected with H and E. The vertex R is connected with H and E. Okay. That means there is no connection between the vertex. I is not connected with F and G. So I is not connected with F and G. So that is RF and IG. IF and IG are the diagonals here. IF and IG are the diagonals. Also for the vertex H, H is connected with I and G, but H is not connected with P and F. That is these two. This what? HE here. HE and HF. HE and HF are diagonals. And remaining to tell is what? Here. Look at here. F and G. E and G. E is connected with I and F. E is connected with I and F. So E is not connected with G. So E G is a diagonal. E G is a diagonal. That means diagonal is what? Line segment connecting to non-consecutive vertices is called as diagonal. Okay students, up to this all of you understood all this concept. First one is what? Closed curve. Okay, open curve. Then polygons. Interior part, exterior part. Interior part has a boundary. Exterior part does not have any boundary. Right? Then classification of polygons according to number of sides and vertices. Polygons are classified into different categories. last concept is diagonals. What is diagonals? Diagonals is a line segment connecting two non-consecutive vertices. Do you remember non-consecutive vertices? How to find non-consecutive vertices? Non-consecutive vertices means what? There is no line segment between these two vertices. If there is no line segment between any pair of vertices, these vertices are called as non-consecutive vertices. And a line segment joining to non-consecutive vertices is called as diagonal of that polygon. Okay students, we understood all these concepts? Okay, so watch this video carefully, listen this video carefully and write out all these concepts in your notebook.